Assalamu alaikum, everyone. So hello to another session. This is Ahmed Bukhari, and I have Sir Fraz Yousafi with me. And I'm really grateful that he took out the time for us, and he was able to help us out in this time of need. Of course, everybody's right on edge right now. So without further ado, let's hear it from Sir Fraz Yousafi.
Assalamu alaikum, everybody. How are all of you? I know it's a tough time for some of you. Ghar pe chand raat bhi ho rahi hai, and then at the same time, we're trying to study. So hats off to you people, the kind of dedication you've had to show and the kind of discipline you've had to have. So we hope for the best for all of you, right? So today, some of you may know me, some of you may not. I've been teaching here in Lahore for about 16 years, O&A levels chemistry, and I've had the pleasure of working with Ahmed and been around quite a few schools and colleges here. And again, we try to do the best that we can to get our students prepared in terms of what's coming onto the examinations, what they need to be looking at. So what I wanted to do today is just kind of focus in on just certain tips, not as such go through a paper as much. I have a feeling that a large number of you have kind of sifted through at least, anywhere from 5 to 10 years worth of examinations. So what we're going to try to do is to try to remind you of certain things, certain ways that you can kind of clean certain things up and hopefully get to the point where you feel a lot more comfortable with some basic points. Now, one thing I did want to talk to you about is certain things that I've seen students struggle with. And that is particularly dealing with, obviously, one of the things that we deal with consistently and struggle with is molds. So I did want to address that kind of with the vast majority of you to kind of make sure that there's certain formulas that are across the board clear and direct for all of us. You should, I hope, be able to see a screen right now, right? And on that screen, what I'd like to do first is to just quickly go down and remind you. And you're going to just quickly see the fan up in my room. That's all right, as long as you can hear me, right? And I think one of the biggest mistakes that we often make is kind of mistaking where all the idea of moles come into play, right? We know that moles as a quantity can be related to several things. Front and center amongst all of them is the idea of mass. Right, now most of you are familiar with this formula. I often see students simply write this formula out this way, which is fine for the vast majority of your compounds and molecules where 2 or more atoms are bonded together, right? However, let's say that it's not just an actual molecule where atoms have simply been bonded together. This is understanding you ought to have. The objective of your book referring to something as molar mass is going to be something that is clear and precise, dealing specifically with the idea of, again, how many grams per mole of any substance you have. And the 2 predominant measurements that you have to be able to look at are going to be MR and AR. All right, if you're going to hang on for me just 1 second, please, just 1 second. Okay, sorry about that. So again, the idea of molar mass, what we want you to kind of look at here is that these are the things that you're measuring the masses of, and they're basically the idea of relative mass. आपको बताया जाता है कि an atom again cannot be measured to compared to again the gram scale. Well, it can only be measured compared to 1/12 of a part of 12. So that understanding should always be in your mind. What we're saying now is when we talk about AR and MR, compared to the idea of moles, is that you're not taking one atom or one molecule, you're taking 6.02 times 10 to the 23rd, right? If you take that many particles together, all of a sudden these masses can be given into values of, as you said, grams per mole, right? That's the understanding we want. So this is one formula that I'm pretty sure most of you are aware of, right? Now, the other formula is that which we refer to as molar gas volume. Now, usually when I ask students to remember this formula, they can do it with dm cubed as well, but oftentimes it's more beneficial to know this one, right? Volume again in cm cubed over 24,000, or as most of you are familiar with, this volume, right? 24 dm cubed. That's the understanding. All right. Now, this is for gases at room temperature and pressure. Okay. One. All right, so gases at room temperature and pressure, either one of those. Now, do keep this in mind. You cannot apply this understanding in any way, shape, or form if you're dealing specifically with the idea of, as we said here, specifically with the idea of anything but gas. Just सबसे बड़ा misconception होता है कि we'll try to take like 25 centimeters cubed of hydrochloric acid and we'll try to apply this formula. You cannot do that. It has to be only true for something that is gaseous at reaction conditions, right? And the one that we struggle with the most, I believe, is this one, right? Moles can be determined by simply taking the volume of any particular solution, again in dm cubed, and simply multiplying it by the concentration of that solution in moles per dm cubed. So again, these are three things that the formulas that are strictly given to you at every type of stoichiometric calculation you can think of. Now, one of these formulas has a much more important, if you will, realistic application, and that is the understanding of empirical formula, right? Because basically the idea of molar mass can be applied to any chemical formula. So let's say I gave you this chemical formula. We all know this to be the chemical formula of ethane, right? So C2H6 की जब बात की जाती है, the thing that I want you to keep in mind is what this is telling me is it's saying that there's 2 moles of carbon atoms for every 6 moles of hydrogen atoms in one formula of ethane, right? That's the understanding. That's the idea. That's the ratio that we use to describe to any particular, if you will, compound or any formula. It's nothing more than a mole to mole ratio of atoms. So this is why when you calculate empirical formula, yeah, look at this first step is when you divide mass by AR or MR, you're actually finding moles of that particular substance, right? So that's the understanding that we want you to have. Now, the idea is that if I just give you any example of a question, the objective of this would be to look at something along the lines of this. If you hang on one moment here, to try to find, again, one question from a more recent exam question. One other thing, if you're going to study, especially those of you that are a little bit worried about different things, different, if you will, nuances or processes being put into an examination question, it would probably be to your advantage to study with the more recent papers. And the reason I say that is because, as some of you may have noted, especially when you were solving P1s, is with the O-level version, the 5070 July series examination, they snuck in something that usually only comes in the IGCSE, and that is the idea of acid base in terms of proton donor and proton acceptor, acids being proton donors, bases being proton acceptors. So you probably, again, would be more beneficial for you to attempt examinations of the more recent variety, because they're going to be more in line with type of paper you're about to get in terms of in about a couple of days here. The other thing I would say is, especially if you've done as many O-level papers as you could possibly do, or on the vice versa side, if you've done as many IGCSE papers as you could possibly do, it probably would be to your advantage to then kind of continue, right, solving papers on the basis of, for example, if I've done like 10 years worth of O-levels and I'm pretty comfortable with what I've been able to accomplish, then it probably would be to my advantage to kind of go on and solve some IGCSE papers, especially the most recent variety. Now, the markages, the number of marks allotted may be a little bit different for each type of examination, but the general knowledge, the general understanding will generally, the process will generally be the same, okay? All right, so look at this question really quickly. It says dilute sulfuric acid reacts with sodium hydroxide. This is an examination question that showed up in the O-levels in October, November 21, paper 2-2, sorry. Student adds 0.76 grams of solid sodium hydroxide to 45 centimeters cubed of 0.2 mole per dm cube sulfuric acid. So if I look at this understand, right, and I compare it to this understanding, they've given you a question where they've provided two givens and they want to know which of the two happens to be in excess. Now, one thing is for a fact, I know that for every 1 mole of sulfuric acid, there have to be 2 moles of sodium hydroxide that are present in order to undergo reaction. Now, what they're saying is that if we give you the mass of sodium hydroxide and the volume and the concentration of acid, can you tell us which of the two? In this case, they want you to prove that sodium hydroxide is in fact the excess reagent. So how are we going to go about doing this? Well, simply put, the first thing you should do immediately is take the information that they've given you and convert that mass, concentration, volume of a gas, whatever it is, convert it into moles. So इधर बेटा सबसे पहला काम होगा कि for each reagent, each one, I'm going to first calculate the moles of each substance. So in the case of sodium hydroxide, I'm going to take that 0.76 that they've given me, and I'm going to divide it by the MR of sodium hydroxide, which is 40, right? The, again, 23 plus 16 plus 1. So you get 40 as your mass, and this in turn gives me now this is the number of moles of sodium hydroxide that you actually have, that are actually present sitting in your system at this particular point in time, right? Now, a couple of things you can do with this, and what I would do first myself is that I would use the same idea and I would find the moles of the sulfuric acid, right? So the formula that we want to plug in here is we want to take the concentration, which is 0.20, and we can divide that by 45 over 1,000, okay? So 0.20 times 45 centimeters cubed, or 0.045, and I end up getting 0.00 9 moles of sulfuric acid, right? So now, just if we're looking at this, again, if you remember, according to what they gave you, for every 1 mole of sulfuric acid, you're supposed to have twice as many moles of sodium hydroxide. So if I have 0.009 moles of sulfuric acid, that means I should have, that's a key word, I should have 0.018 moles of the alkali, right? So if I wanted to get rid of all of the sulfuric acid, which is 0.009 moles, I need to have exactly twice as much of my alkali. So this is how much that I would have. So if I compare the two, what I realize, that's how much excess of the sodium hydroxide that I've got. Even once all of the sulfuric acid is used up, which makes the sulfuric acid the limiting reactant, by the way, this is how much alkali would be left over behind as a result. Any questions, any ideas, any issues that you have, you can put this onto the chat. We can follow along so you can actually see what's taking place and understand. All right. Okay. All right. Now, let's kind of head on back to the generalized screen if I could. So that was one major issue that shows up very often. Now, another very important point is knowing the paper format, knowing the breakdown. So most of your theory papers, whether it's paper 2 in O levels, whether it's paper 4 in IGCSE, they tend to exhibit very particular patterns. As some of you may have noted, those patterns have wide-ranging different questions, but there's certain things that keep repeating, that just keep showing up over and over and over again. For example, you're going to see questions on atomic structure. And when I say atomic structure, one concept they specifically love, especially in paper 2, is the idea of isotopes and ions, right? Being able to determine how valency dictates whether something loses or gains electrons, being able to dictate or the understanding that there are atoms with the same proton number with different neutron numbers that also tend to exist, right? These ideas tend to show up quite often, more so than not. Beyond that, bonding and structure. More importantly than just knowing the basic ideas, which you could, they can ask you very straightforward questions on how an ionic compound is made between, let's say, magnesium and chlorine, where you'd have to get across to them that magnesium loses 2 electrons and a chlorine molecule gains 2 electrons, or 2 chlorine atoms each gain 1 electron apiece to form the ionic compound magnesium chloride. They can also ask you about, again, dot cross diagrams. They love dot cross diagrams, especially more recently, dot cross diagrams of double bonded substances or triple bonded substances. So you understand where elements are having to share multiple electrons, more than just a pair, multiple pairs of electrons, and understanding the idea how you would show that representation, right? They love asking you to compare, by the way, ionic and covalent bonding, especially in IGCSE. That is a staple question where they will ask you to come up with different questions about ionic bonding. If we go at structure, they think is sometimes they will just give you properties that they can randomly ask you. And then along with all of that, they're also going to ask you to specifically focus in on, along with those things, they're going to ask you to focus in on comparing the intermolecular forces. So one of the things they love is once you've kind of addressed what the structure is for a particular substance. So if I was comparing, let's say, sodium chloride to hydrogen chloride, that's one like kind of idea that they can go with. You'd be able to determine that sodium chloride has a giant ionic structure. Hydrogen chloride has a simple covalent structure. The thing that they want to know most importantly would be this. What is holding each structure together, as opposed to what you see there or what you end up seeing? Right? And they definitely want you to be able to determine certain things. So a huge number of questions, particularly in the IGCSE, want you to compare why, again, a giant ionic lattice has such a high melting point and why simple covalent structures tend to have very low melting points, right? And you'd have to intertwine these ideas into them to be able to get your answers across, okay? Any questions there? All right. Now, after bonding and structure, I often ask students like how much they know about acids and salts, but this topic does show up. It so all right. So acids, bases, and salts, particularly a lot more focus, especially on both syllabi now, are dealing, as you can see, with this particular topic, salt preparation. So they love asking students to come up with ideas of salt preparation, given a particular salt. Right. I see a question here from Atomic Structure that I want to kind of just address before I go forward round. Khudam has asked, Sir, there was something about the forces attracting each other's nuclei, right? Well, you've got to be more specific than that. So when we're talking about forces attracting each other's nuclei, you're actually going into a detail of a more direct definition of covalent bonding. So I do want to just quickly get that in purpose across to you, but then I want to also give you a slight default idea there. So here is a covalent bond, as you can see, two atoms sharing a pair of electrons. Now, what we've been told in O levels is that they're two both non-metal atoms, they both want to gain. So they end up sharing that pair of electrons in order to remain electronically stable. However, in reality, here's what happens. There's a hydrogen proton there, let's say, for example, and there's a chlorine nucleus with 17 protons, both sitting towards the center of each atom. And this pair of electrons that happens to be shared between them, it happens to exhibit a negative charge. So here's what ends up happening with them. The actual positively charged nuclei are both attracted to that negatively charged shared pair of electrons. That's what binds the atoms together. That's what keeps them together. Just like when we talk about ionic bonding, it's an attraction between oppositely charged particles, positive and negative. In reality, this is what a covalent bond does. However, having said that, I'm going to put this to a side and I'm going to say, I would ask you to kind of forget this for the next couple of days, and I'll tell you why. You do not need to know this for the O level or the IGCSE examinations. This is beyond the scope of your syllabus. This is more of an AS concept. They do not expect you to be able to tell them that that's what keeps a covalent bond together. So what they do expect you to simply know about a covalent bond is that it is a sharing of electrons between two or more non-metal atoms. So I would not add at this point onto anybody's plate something that might confuse them and it's a little bit beyond the scope of their understanding. I would focus my answers strictly to what I'm supposed to know. And there is no mark scheme that will give you marks incorrect or telling them that a covalent bond is a sharing of electrons between two or more non-metal atoms. Nobody can mark that wrong. Okay. All right. Thank you, Mohammed Fahad. And random question here: how many papers are enough? Always love this question. The answer is there is no answer. However, if you do quality over quantity, that matters a lot. Now, what do I mean by quality over quantity? I always tell students if you manage to do quality, 5 years is more than sufficient. Where if you can just take even your variants and you sit down with 5 years worth of papers and you go through them in terms of quality, where you go through every question, you solve the question, you check your answers using a mark scheme, and then go back and correct those things that you've gotten wrong. That's the key point. सबसे बड़ा मसला ये होता है कि when we check our work, हम आगे बढ़ना चाहते हैं, हम दौड़ पे लग जाते हैं कि भाई अब मैंने ये वाला कर लिया, now I need to do the next one. That's not sufficient. आपने अगर ये वाला कर लिया, for example, let's say I did this and section B में, if I talk about O levels, तीसरे क्वेश्चन पे आपको बिल्कुल सी पार्ट का कुछ समझ नहीं आया, पता चला आपको कि सी पार्ट इलेक्ट्रोलिसिस का है, तो इसका मतलब ये है कि you need to go back and you need to revise electrolysis, particularly that electrolytic circuit. चाहे जो भी आपकी गलती है उसको उसी वक्त correct करे बेटा. If you can correct that mistake, you're not likely to cause, or you're not likely to make that mistake again. It will remain constant without you having to do anything further. So I think when I say quality over quantity, that's what I'm implying. Are we actually correcting our mistakes and understanding our mistakes before we move ahead? You can do 15 years worth of papers and understand nothing if you just keep saying, I kept getting it wrong, but what did you do to fix what you got wrong? Right? So it's imperative that you somehow go back and enhance the quality over the quantity. All right. Salt preparation thoroughly karna padega, especially because ab dono IGCSE or O levels में बेटा they specifically focus in on questions. So let me show you what I mean. Let's say that we're talking about our O levels, right? In terms of the O level chemistry syllabus, they specifically love these questions where they will say briefly outline the steps to prepare a pure dry sample and that's where the variation comes in of any particular salt. I will say this, that they have actually started to make things a lot more easier than they used to be. बहुत पहले ना, they would just give these questions randomly, salt का नाम पकड़ा देते थे, and the students had to come up with everything. But now they will imply certain things. For example, वो लिख देंगे question पे पहले हिस्से में कि zinc nitrate is soluble in water, zinc carbonate is not. And then they'll turn around and say, briefly outline the steps needed to prepare a pure dry sample of zinc carbonate. Basically, वो आपको ये बताना चाह रहे हैं कि please outline the steps needed to make an insoluble zinc carbonate salt. They want precipitation, and they want you to walk through that process of precipitation. The other possibility was that when, again, you're going through the next part, let's say they talk about the idea of reacting an acid with an alkali. They want you to jump onto the fact that you now need to briefly outline the process of titration. That means the indicator should be mentioned initially. Once you've done it, then you need to repeat it without the indicator. That's the kind of steps that we want to be able to have, right? So yes, I would say that you do need to study it to some detail क्योंकि ये सवाल periodically आते हैं. Now, they're not a huge part of the paper. So for example, 3 से 4 marks एक salt पे आ जाएगा. उसी सवाल में फिर किसी और salt reaction की equations आ जाएंगी. और उसी सवाल में for example ionic equation precipitation की भी आ सकती है. और इस तरह वो उठा के 5 से लेके 6 या 7 marks salt के link करके आगे चल जाएंगे. So is it a massive part of your actual examination? It's probably not. Mixed with acids and bases, can it be anywhere from 5 to 10 marks? Obviously, which is a significant portion considering your paper is 75 marks, right? Now, in the case of IGCSE, again, they're going a lot more into salts every year without fault. Check the exams that you've been studying with, that you've been solving on your own. You will find a salt question somewhere. But the difference is they focus more on procedure and observations here than they do so with the O-levels exams. For example, they love asking the adding of the insoluble base to an acid solution in excess, and then walking through the entire set of steps, how you would filter out. Like the last stuff, like why did you add the excess of the insoluble base? And you needed to be able to tell them so it would neutralize all of the acidity. So this is a very, very common question that shows up, okay? So again, when you say, do we need to do detailed versions? Like I said, not perhaps into excessive things, like recall knowledge like you would see, let's say, in P1. But what I would say is simply the idea of going through and looking at the processes that would be helpful, very much so. Should we try Excel papers at this point? Man, I would not. I would honestly tell you at this point, I would not put anything excess on my load, especially anything that's pertaining to giving me questions out of syllabus. Now, if you, I'm not when I say out of syllabus, out of format, I should say that. I would much rather you read questions in the format of the Cambridge exams that you're more likely to get than any other board. Now, having said that, if you've done like 20 years worth of papers according to your board, I think then maybe you can branch out. But I think even then, there's always this leftover room. कि अगर आप O level कर रहे हैं, so that you've done O level questions, but you've not done IGCSE. So instead of going all the way to Excel, you'd be better served to go to IGCSE. And I promise you, you're going to see a lot of repetition that way. चीजें repeat होना शुरू हो जाएंगी. For example, वही ionic compound के बारे में एक दो चीजें similar तरीके से पूछ लेंगे, even though the questions will then have a third part that's entirely different. But you'll see that there's going to be nuances that are linked together. With the Edexcel, the problem is that the syntax of the question, the way that it's worded out, may not be to your benefit. It may end up being slightly off of what you're accustomed to and what you're used to. So you may be able to understand the question and you may think it may be very easy. And then you open up your Cambridge exam and it may seem slightly more difficult to you because sometimes the formats are there. Some questions, for example, in Edexcel and OCR that are way more difficult. But there's certain questions that are ridiculously easy. And when you put them side by side with O levels, you realize, wait a minute, this is not anywhere near the type of question I'm getting. So when I generally, for example, I do this a lot with my students, I put exam questions from a multitude of sources. My objective is try to find papers that show some kind of difficult abstract logic. I want them to, for example, if they've been accustomed to writing out, all right, here's the atomic number, here's the proton number, mass number, how many protons, neutrons, and electrons, I'll start asking them to start looking at isotopes because I want them to start thinking another way around. So if something surprising happens in P1 or P2, they're accustomed to at least knowing that this could occur. However, in the next couple of nights or tonight and tomorrow night, I would not be playing around with Excel papers right now. I'd be focusing more specifically on my format examinations, and I'd be focusing on correcting my mistakes there. Large Number of my classes that I teach, students have become accustomed to hear something about learner guides. Those learner guides are invaluable tools because they're checklists. And I keep telling them that while you're solving past papers, that learner guide should be right there in front of you. So you can sift immediately to the topic that you struggle with or you got wrong, and you know what that topic is. You can look it up a lot sooner. And then you can even check to see, all right, this is one of those topics that I had to have a couple of revisions done, or even after one revision, I wasn't as clear. And so I'm keep continuously getting those questions wrong. Then you know how to attack a topic, right? Instead of just randomly attacking things. Okay. All right. As we were going through, after acids, bases, and salts, there's a huge section of, in A levels, what we simply call physical chemistry. And all of these parts of physical chemistry, none of them are going to be like not specifically present. They're all going to be there across the board. Um, Abdullah Bilal, I would at this point in the next couple of nights focus in on my variant, especially with O levels, because अगर आप नोट करेंगे दूसरा variant कोई इतना खास different नहीं होता. आपके variant से they just change chemicals around. They almost are asking the exact same questions as well. So it really would not be to your benefit to do more different variants as it would be to do different years. Okay. Now, physical chemistry. So we're back to this idea. What all does it involve? These are the topics that are involved: energy, rate, and equilibrium. So you're definitely going to see questions on all of these. And I'll be very honest, you're looking at anywhere for a grand total of 20 marks from this topic. You're going to see questions on rate. Graph question हो सकता है, factors के बारे में हो सकते हैं. One thing I do want to get across and make sure it's clear for all of us. Usually, this is a concept that is very familiar to all of us. And when we've been able to, when we've been asked to explain something like this, we've done it in a very simple manner without a large amount of issues. Then they turned around and last couple of years, they did it first in the IGCSE, and then they did it in the GCE. They started to make this question worth 3 marks. Used to be straightforward, used to be 2 marks. Then they started to sneak it in for 3 marks, and they said, all right, why? How come? Kabhi kabhi, what they would do is they would just say increasing temperature, what would happen to rate, and explain. So one of those marks was simply for you telling them that rate went up. But that phrase in itself is not the entirety of the answer. So what all is it that we want? Now, if it's 3 marks, what is it that we need to be able to tell them? So I want students to have this in their mind entirely, that you need these couple of phrases that will become extremely important as you progress. If I'm increasing temperature, the first thing I'm going to do is I'm going to make sure that I've got this across to the examiner. The particles have gained energy and they are now moving faster, right? But that's only part of the deal. The next part I need to talk about is this. All right. So there are more particles with energy greater than or equal to activation. That is, again, something that most students did not have the habit of telling the examiner. And so this is what they're sneaking in. To be very honest, they're linking your concept to A levels here. Just like somebody asked about the covalent bonding, they haven't entirely done that with the covalent bonding. They still are differentiating the answers and the conceptual knowledge for O levels and IGCSE as opposed to AS and A2. But here they're not so much concerned. They do want to link these things together because you don't really study a lot of rate in AS. It's mostly nothing but revision of O levels and IGCSE. So this is a conceptual idea that they want. So particles gain energy, move faster. There's now more particles energy greater than or equal to activation, which in turn increases the frequency of collisions, increasing rate of reaction, right? This is the way we want to go about doing this, okay? Any questions there? So just going to quickly all right, Abdullah Omar, question is how many marks should we be scoring at this point out of 75? Let's be very straightforward here and be honest. I think one of the things that's important that we need to make sure that we're honest about is we need to gauge our reality. If we've been struggling for 2.5, 3 years, if we've been consistently getting grades that are in the lower, for example, let's say C's or higher C's, then you need to be able to kind of, hopefully, you're obviously aiming for something higher, but you need to be able to be realistic about if I want to get an A or if I want to get an A star, right? So I would honestly tell someone who has an objective in their mind of getting an A star, out of 75, you need to be aiming at, given threshold ideas and everything that change. So there's no absolute there. You should be aiming at above 60. To be very, very honest, in order to get an A on this composite paper, P2, no, there's no A star on a composite paper. So whether it's P2 or whether it's P4 for IGSE, there's not a set grade that you can get as an A star. The maximum you can get is an A. I would say for P2 in O levels, something above 60, and P4 because it's I believe 80 marks, somewhere probably above. Same thing about 65, 66. Above that is where you need to be to safely have an idea for an A. All right. Do we need to mention kinetic energies? Then you can. You don't need to, because technically, kinetic energy, the बाद में बनती है, it's actually gaining heat energy, right? It's being converted to kinetic. So it's not a physics class, so they don't want ideas of conversion of energy. It's just the idea of them gaining energy is more than sufficient, right? All right. It says here, so what should we do in these next 24 hours to revise notes? Yeah, revise book. I would actually revise notes at this point. I think I would only use the book if there's something that I simply cannot get clear across. If I'm not able to access a teacher, access another classmate, they can help explain it to me in a more thorough manner. I would not be sitting with a textbook. You don't have the time. I would go through the notes and I would relate those notes to past paper questions now more than ever in the next 24 hours, right? You can call it successful collisions. You can call it effective collisions. You can even call them fruitful collisions, either syllabi, 50, 70, 0620, doesn't matter. They generally think of them as exactly the same thing. Okay. Those aiming for distinction, again, it's a very good question. If you're aiming for distinction, then you definitively need to make sure that you're aiming above. I would say if it's 75 marks, you should be aiming at 68 or above. If it's 80 marks, you should be aiming at 72 or above. This is where you need to be in terms of markage. So you come well above the threshold, or in fact, you kind of set the threshold accordingly. Okay. That's the idea that we want. Now, as I was kind of going through, so we talked about physical chemistry. Uske baad, there's a link between another 3 set of types of topics that kind of intertwine together. And that is your redox, your electrolysis, and your reactivity. So these 3 will be linked kind of together as well. And they generally range together anywhere from about 7 to 12 marks. You're probably going to see something with redox for anywhere from 3 to 4 marks. Redox confirmed आएगा. And any definition, by the way, simple वाली हो सकती हैं, organic reactions दे सकते हैं, loss of hydrogen, gain of oxygen, electron transfer का दिखा सकते हैं, where something is losing, something is gaining. They don't focus as much on oxidation numbers, although that's going to change, especially in 2023. So I have a feeling that kind of stuff will sneak into your paper because, again, simply looking at the charge of a particle is one of the easiest ways of describing redox. Now, ek baat yaad rakhe, if you decide to use the oxidation state explanation to define oxidation or reduction, it's not enough to just say for oxidation state increases. You have to tell them how it increases. So, for example, if I showed iodide becoming iodine, I minus turning into 2I minus turning into I2, I have to tell them that the oxidation state increases from -1 up to 0. That's the objective. That's the idea, right? Same thing for the reduction. I need to tell them not just the decrease idea, I need to tell them the exact decrease itself. And then somewhere along the way, ideas of simple cells, thermal decompositions, those two tend to come very little, however they can. However, displacement reactions, extractions, and reduction reactions. For example, basically displacement and reduction reactions are the same. Sirf fark ye hai ki displacements occur in solution, reduction reactions occur without solution. But they're doing the same thing. The more reactive is oxidizing itself, and the lesser reactive is being reduced because of it, right? So that is another conceptual idea that you should have in mind. Zen Hassan, again, if you've got time, there's certain things that will help. The problem is sifting through the papers and using which ones would be helpful for O levels is not something I would tell you have the time to do right now. Some of you may have that capacity if you have more time. Given that you've got a very small amount of time, you don't want to put yourself at that risk. So, for example, atomic structure के question अक्सर A level के O level के साथ correlate हो जाते हैं. But I would not, again, like I said, I would not do anything that makes you think it's कुछ चीज syllabus पे है जो नहीं है. That takes you away. For example, वो bonding की बात अगर हम लिखना शुरू करते हैं, कोई examiner उसे गलत नहीं mark करेगा. That's the thing. क्योंकि technically वो भी सही है. मसला सिर्फ ये है कि it's not what's required of you in terms of your exam. So you're learning something that is going to be not something that they can turn around and ask you. And it's just kind of putting wasted effort that you could put somewhere else, right? All right. Yeah, it's just importantly, and Abdullah, in terms of environmental chemistry, the major things I would tell you: separation of air and composition. Take the yoga. But majority of the questions, 9 times out of 10, Abdullah, pollutants, their effects, and the sources, their effects, and in some cases, their preventive measures. So, car exhaust के questions अक्सर आते हैं. Oxides of nitrogen, carbon monoxide, इनके असर, and then they talk about the catalytic converter as a preventive measure. Then they focus in on acidic rain due to sulfur deposits being combusted into SO2. So ये एक common सवाल है. And then how you have to go through flue gas desulfurization to limit the amount of sulfur dioxide that's being put out into the atmosphere. And then obviously the carbon cycle, photosynthesis and respiration working hand in hand, and how combustion causes the imbalance and allows the CO2 concentration to increase. So those would be the only things that I would tell you from environment, from atmosphere and air, atmosphere, and water that are intrinsically important. So you're not going to see a lot of those. Those are generally very elementary concepts. So that's why they don't want to ask too much on them. But the separation of air is linked to separation techniques. वो उसको बिल्कुल link कर सकते हैं. Process physical property के बारे में discuss कर सकते हैं. Which physical property is responsible for that separation, right? But mostly they love pollutants. They love where they come from. They love what they do, and they love how we can perhaps try to prevent some of them from escaping to the atmosphere, right? So we get rid of those topics. There's only pretty much one left. And I think most of you are familiar with this part, and that is organic chem, right? This is the one that we generally spend the most time focusing in on. Now, there is one nuance that I do want to focus in on, and that is naming. There is a slight difference between your two syllabi that you should be aware of. So in O levels, they don't care where you put the OH, it's just propanol. Very rarely, if ever, do they hark on questions where the position of the OH becomes important. But in IGCSE, they will not, in most questions, score the mark unless you are specific to where your functional group happens to be. And what these numbers are telling me are the positions of where the OH would go. So that is one nuance in terms of naming that they're both different in. You are not to name any branched isomer structure at all. Doesn't matter whether it's O levels or IGCSE, that's not a part of your syllabus. You're only required to know straight chain names. And then if they give any variations, either they will name those variations themselves, or the questions will have everything to do with their physical properties and their chemical reactions, but not about naming the compound in any way, shape, or form. So it's a big misconception. People try to name these branched isomers. Don't do it. It's not something that they can ask you. I would much rather you take that same effort and you put it into the reactions that occur and how those reactions happen to occur, rather than focusing on how to name all of these substances. Another thing that would be important is when we talk about alkenes, understand that it doesn't matter how many carbons are on the alkene, addition can and only occur over the double bond. So for example, if I wanted to show a product that would form by reacting butene with, let's say, bromine, then both bromine atoms would be on adjacent carbons. I think वो जो सबसे बड़ी गलती है कि बच्चों को लगता है कि हम ऐसी भी कोई स्ट्रक्चर वेरिएबिलिटी ला सकते हैं कि एक पहले पे दूसरा चौथे पे जाके लग जाए. ऐसा नहीं हो सकता. Both and whichever atoms attach onto the alkene structure in the process of addition, they do so at adjacent carbon atoms, not carbon atoms that are any distance away, because you need the carbon-carbon double bond. सवाल मैं बता देता हूँ आपको क्या breakdown होता है, चाहे IGCSE हो या O level हो. The breakdown is very simply कि एक सवाल homologous series का आता है हमेशा, ठीक है, उसमें या alkane alkene link होते हैं साथ, alkane alkene इसलिए link होते हैं कि there's a diagnostic test different, there's a difference between the functional groups, so there's a difference in describing those things, right? So एक diagnostic difference confirmed आती है, general formula के सवाल आप पूछे जा रहे हैं दोनों syllabi में कि how do you know it's an alkane, and you have to focus in on the CnH2n plus 2 idea, right? Uske baad, the other two homologous series that they love linking together are alcohols and carboxylic acids, because there's so many reactions linking them to one another, even though they are reactions in alkenes to alcohols as well, but they love that. By the way, IGCSE mein, they love comparing the two preparation methods of ethanol, whether it's catalytic addition of steam or whether it's fermentation. They don't do that a lot in O levels. They still want you to know both of them, but they go into extensive details about the pros and the cons of each process comparative to one another, right? Know that, by the way, fermentation is a renewable preparation of ethanol, right? Also, once you've gotten past that, they love the alcohols, the carboxylic acids, give it a whoop, esters be what consequent. And then the second type of question that you're definitely going to see is going to be something about polymerization. Now, they've gotten more into the habit of not focusing on any one type of polymer anymore. So एक ही सवाल में mix and match करके addition polymer, condensation polymers, दोनों को mix and match करके दे देंगे, कभी monomer मांगेंगे, कभी polymer मांगेंगे. It is imperative that you understand a condensation polymer is any polymerization where, again, right, small molecules like HCl or water given off as byproducts. All right, quickly. Do you have to memorize the monomers of some synthetic polymers in the book? No, you do not. That table that they've given you that said polychloroethene and all of that. The only ones, and even then, I wouldn't say you have to memorize them, but you need to know what functional groups I happen to be on for both of them is terylene or polyester and nylon and polyamide. So अगर terylene और polyester की बात की जाए, आपको ये पता होना चाहिए कि एक monomer double acid है, दूसरा double alcohol है. आपको ये भी नहीं पता होने की जरूरत है कि अंदर वो जो boxes बनते हैं उनमें क्या है, ठीक है? Although to be very honest, उन्होंने boxes को avoid करना शुरू कर दिया है. बहुत रिसेंट सवाल आए हुए कि बॉक्स की जगह उन्होंने आपको बता दिया कि भाई एक कार्बन है, दो कार्बन है, चार कार्बन है, क्या उन बॉक्सेस के अंदर है. But the general understanding is the only reactions occur at the functional groups, right? So चाहे वो डबल एसिड्स हो, चाहे वो डबल अल्कोहल्स हो, और अगर नाइलॉन की बात होती है तो फिर डबल एसिड और डबल अमीन हो जाएंगे. So that's the way you're going to be able to differentiate or understand कि आपसे क्या मांगा चाह रही है. You're going to need to memorize the functional groups. In the case of addition polymerization, you do not need to memorize any particular type of addition polymer, but you do need to be able to convert from the monomer to the polymer by getting rid of the double bond and adding repeat units together, or vice versa, from polymer back to monomer by identifying a repeat unit and reforming a double bond. Okay. If we were not giving ATP, how should we score in theory and MCQ exams for A star? And I hope I pronounced your name right. Ainab or Anab. You need to ensure if you're not taking P5, P4, I should say, sorry, or P6 in IGCSE, इसका मतलब ये है कि जो भी वो मार्केट है, पर लेट्स से आपका अगर IGCSE की बात करते हैं तो वो 40 मार्क्स है. तो आपके ब्रेकडाउन इस वक्त क्या है कि 40, 80, 40, राइट? तो वो 40 मार्क्स अब क्या करेंगे कि वो 40 मार्क्स आपके P2 और P4 पे डिस्ट्रीब्यूट हो जाएंगे. तो जो आपका P2 था जो पहले 40, उसको समझो वो तकरीबन 60 मार्क्स का हो जाएगा, और जो 80 का P4 था वो 90 का हो जाएगा. तो आप ऐड करो 50, 90, इट्स द सेम 140, इट्स जस्ट दैट द परसेंटेजेस आर नाउ डिस्ट्रीब्यूटेड. अब अगर आपकी कोई गलती P2 पे होती है वो ज्यादा हाइटेंड हो जाएगी, अगर आपकी कोई गलती P4 पे होती है वो ज्यादा हाइटेंड हो जाएगी. तो योर pressure in terms of scoring A's on both of the paper goes up tremendously, right? They both now have to be A's as where they weren't before. I hope that helped. Is there anything also? Hanya Ajmal has asked, is there anything as expected topics in chemistry? If so, then which topics are the most important for the upcoming exams? So I would strongly tell you that it would be organic chemistry, most definitely. You will note I didn't mention moles anywhere though, even I started with that. ये moles कभी specific एक topic नहीं होता. वो कभी salt के साथ अटका दिया जाता है, कभी वो reactivity के साथ अटका दिया जाता है, कभी वो organic के साथ अटका दिया जाता है. So there's not a specific place where you're going to just see a moles question. It'll be kind of linked in everywhere. But the point is that I would say organic chemistry. I would specifically say physical chemistry, just my energy rate or equilibrium, and chemical bonding and structure. If you can go through these three things, you give yourself a much better chance of then making sure that you can focus a little bit on the periphery. What I always tell students, these are going to be the meat of your paper, and everything else will be the condiments around that meat, right? So, Harun Nadeem, what about the separation of polymers by hydrolysis? Again, absolutely important. That reaction in itself shows up, but it shows up more in IGCSE. It shows up asking you to draw a lot of structures. For example, आपको nylon दे देंगे और आपको कहेंगे कि भाई हमने ये किया, hydrolyze किया, तो पीछे क्या बना, और वो specifically proteins के साथ भी ये करते हैं. However, O levels में they're not as concerned about the structure of the amino acid that you get at the end. They're just simply asking you कि बनेगा क्या. O level वहां पे खुश है, वो कहेगा कि भाई ये प्रोटीन कॉम्प्लेक्स है, इसको हमने हाइड्रोलाइज कर दिया तो क्या बन जाएगा, तो you have to tell them कि भाई अमीनो एसिड बनेंगे. IGCSE उस अमीनो एसिड के स्ट्रक्चर मांगे. IGCSE उस फैट के स्ट्रक्चर में जो वो E वाला स्ट्रक्चर बनता है ना, जो ट्रायोल बनता है, वो आपको ये बताना शुरू कर देगा फैटी एसिड जो चेन्स है उनमें अनसैचुरेशन है, सैचुरेशन है. तो IGCSE थोड़ा और आगे हिंट करता है, पर they both focus in mostly on hydrolyzing and breaking the functional groups. All right. So Harun asked that question. Fahad says, how many significant figures are all answers should be to 3 or 4 significant figures. If they are whole number values that end on their own, then you don't have to worry about that. But any repetitive decimal value needs to be done to 3 or 4 significant figures. Rida Rana, when do we shade alter? You don't have to do that, Rida. I'll tell you why. Usually जब वो आपसे कुछ करवाना चाहते हैं ना, वो पैटर्न आपको वो पेपर में खुद दे देते हैं. तो फॉर एग्जाम्पल अगर आपसे मोनोमर से पॉलीमर बनाएंगे ना, तो वो क्या करेंगे, वो डब्बे पहले खुद बना देंगे, स्पेशली इन आईजीसीएसई. वो डब्बे खुद बना देते हैं, आपने सिर्फ उन डब्बों के बीच लिंकेजेस दिखानी है. दैट्स इट. आपको उन डब्बों को शेड करने की कोई जरूरत नहीं होगी. However, if you're doing it, I would follow whatever pattern I see on the monomers. अगर मुझे monomer में एक, for example, double acid में shaded नजर आ रहा है और double alcohol में blank नजर आ रहा है, I would use that pattern because I need to show correctly कि alcohol का box कौन सा है और carboxyls का box कौन सा है. सही है ना? All right, I think this brings us to a close. So I think I hope this has been helpful. I've tried to get hit as many things as I possibly could to remind certain things to you people as you sit down today and tomorrow. Again, hats off to you all for your hard work. Keep it up. I know you've got a tough thing going on tomorrow. Those of you that are going to go to eat namaz and partake, do dua for yourself. And there's nothing wrong with asking for help, especially that help. There's no better help than that help. Others, obviously, it's going to be tough to kind of cut yourself off from your family and the festivities, but thoda sa himmat kar le beta, get through this, and then inshallah 2 years down the line it will be a lot better. You won't be taking exams in Eid or Ramzan. It'll be considerably a little bit earlier for you guys. So having said that, um, keep up the good work. You all, some of you have access to Sir Ahmed Bukhari, others have access to me, and you all have access. Some of you have access to your teachers. Use whichever access you've got. However, if the teachers are able to respond in a timely manner, that's good. If they can't, don't be disrespectful. But if not, share notes with one another. I know I share notes with my students, and I always ask them to share them forward with their other friends and stuff. Help each other. One of the biggest things I've found as I'm watching even my class groups go on is that the amount of effort that some of you put in to help each other, you don't understand how much you're learning in that process. Some of you have become experts explaining to others what's going on, and that is an invaluable tool. I'm not saying sit on your phones all day. You don't have time for that. But if you use it wisely, if you're helping each other, it's such an invaluable tool. खुद यकीन नहीं होगा कि how many things you've cleared and answered and explained to one another simply by helping answering questions for one another. All right. All right. So that's off to Sir Ahmed Bukhari again. Allah Hafiz. Best of luck. And Eid Mubarak to you all, boys and girls. And I hope you all do well. I hope you all succeed and hope to see some of you in the future.
Thank you so much, sir. Thank you so much for such a meaningful session and for helping us out. Really grateful कि आपने वक्त निकाला. And yeah, Eid Mubarak to you and to all the students here. Or I think जो end पे sir ने बात की है, that sums everything up. That help each other, and that is the key to success. Thank you so much, sir.
Thank you. Allah Hafiz.
Allah Hafiz.